Am I audible? Am I audible?
Yes, sir.
Okay, fine. So in the class we are going to discuss repeated eigenvalue. The problems in repeated eigenvalue. Last two problems are non-repeated eigenvalue. This problem we are going to discuss with the repeated eigenvalue. Eigenvalue, eigenvectors. In the bracket I can write repeated eigen. Fine, in the non-repeated eigenvalue there is no problem because you are finding that eigenvalue and eigenvectors others separately we can find. That means if eigen values are not repeated, there is no problem because surely you will get that a very simple solution of the eigenvectors. But when the eigen values are repeated, then you have to find that eigenvectors very carefully. Okay, so first we can write that some note. What is that important note is, if the eigenvalues are distinct, all the eigenvectors are linearly independent. That means there is no related there is no relation between that two eigenvectors. At the same time, the eigenvalues are repeated, then the respective eigenvectors may be linearly independent or linearly dependent. But you have to be carefully find when it is a symmetric matrix. It is for the general matrix. The add one point is there. If the eigenvalues are repeated for the symmetric matrix. It is only for the symmetric matrix. Symmetric matrix. The eigenvectors should be the eigenvectors should be linearly independent, because in the orthogonalization, that means diagonalization by using the orthogonal transformation, at the time we have to be carefully calculate the eigenvectors, because if the rule is compulsory satisfies, then only we can find that the diagonalization map of the matrix by using that orthogonal transformation. Okay, first problem for the repeated eigenvalue. Find the eigenvalues and eigenvectors for find the eigenvalues and eigenvectors for A equal to 211, 232, 334. So here the given matrix, write the solution for this. The characteristic equation is mod A minus lambda I equal to 0. You should be view this folder. Okay, should be somewhat convenient to me. So the characteristic equation is A minus lambda I equal to 0, that is lambda cube minus A1 lambda square plus A2 lambda minus A3 equal to 0. What is A1 here? A1 is sum of diagonal elements of A, that is 2 plus 3 plus 4, that means 9. Second one is A2. A2 is sum of minus of diagonal elements. So what are the sum of minus here? 3 2 3 4 for the first diagonal, 3 2 3 4. For the second diagonal, 2 1 3 4. When you are writing this, you have to be very carefully write this minor 2 1 2 3. Okay, so here you will get that 12 minus 6 plus 8 minus 3 plus 6 minus 2. So this value is 15 plus 15. 12 plus 6 is 6 plus 5 11, 11 plus 4 15. Okay, next one, determinant of A. A3 is determinant of A, that is equal to 2 into 12 minus 6 minus 1 into 12 minus 6 plus 1 into 2 3 6 minus 9. So 6 minus 6 and then 3 and 6 minus 9, total 6 into 12 na, 12 minus 6 6 6 plus 6 into 12, 12 plus 6 18 minus 9. So you have to carefully calculate this. Cos 2 12 minus 6 is okay, minus 1 into 12 minus 6, okay, plus 1 into 2 3 6 minus 9. Okay, so 2 into 6 minus 6 minus 3 na, so that means 2 into 6. But here it is, determinant of A is, answer is 7. Are you doing this problem? 211, once again I can write the 211, 232, 334 is correct. Okay, two things are correct again. 12 minus 6 is correct. Minus 1 into 2 into 4, no? 2 into 4, 8 here. 8 minus 6, so you have to be calculated carefully. 2 minus 2, we get 7 plus 7. So lambda cube characteristic equation is, the step is very important. Lambda cube minus a1 lambda square. A1 is 9 lambda square plus 15 lambda minus 7 equal to 0. So using the synthetic division method, 1 minus 9 plus 15 minus 7, adding all the value, you will get that is equal to 0. Therefore 1 is the root. Put 0 here. 1 into 1, 1 minus 8 is 7, 7 0. So reduced value is lambda square minus 8 lambda is 7 equal to 0. Therefore if you are solving this, you will get that lambda equal to 2 roots 1 comma 7. Therefore the eigenvalues are 7 comma 1 comma 1. First you write the non-repeated value, then you write the repeated value. To find the eigenvectors, heading, find the eigenvectors. So to find the eigenvectors, a minus lambda into x equal to 0. So when the given matrix is 2 by 2 matrix, then the eigenvector is only x1 x2. When the matrix is the 3 by 3 matrices, then x should be always x1 x2 x3. Okay, it is depend upon the case. Now a minus lambda I you have to write. What is a is given, a equal to, I am writing here, 2 1 1 2 3 2 3 3 4. So 2 minus lambda 1 1 2 3 minus lambda 2 3 3 4 minus lambda x1 x2 x3. Case 1, can take this as equation number 1. Case 1, when lambda equal to 7. When lambda equal to 7, the equation becomes 2 minus 7 is 5, 5 1 1 2 minus 4 2 3 3 minus 3. Here x1 x2 x3 equal to 0 0 0. Now we can write that x1 x2 x3 x1 x2 5 1 1 5 1. Second one is 2 minus 4 2 2 minus 4. It is not compulsory you have to take that first two row. You can take any two non-identical row. So x1 divided by limit x1 1 1 minus 4 2 x2 leave this 1 5 2 2 x3 is 5 1 2 minus minus 4. So from this we can find x1 is 2 plus 4, x2 is 2 plus 2 minus 10, 2 minus 10, x3 is 20 minus 20 minus 2. Minus 20, it is minus 4 now. It is x1 by 6, x2 by, I think here, sorry, it is 2 minus 7, minus 5 now here, minus 5 1 1, 2 minus 4 2, 3 3 minus 3. So here minus 5, here also minus 5. So minus 5 here, then 2 plus 10 1 3 plus 20 minus 2. Therefore x2 by 12, x3 by 18. So this one equal to 1 2 3 case 2 and lambda equal to 1, and lambda equal to 1, what you get, 1 1 1 1 1 1. Second row is lambda equal to 1 na? 2 2 2. Last one is 3 3 3. See here, all the rows are identical in the ratio. Even if you are solving that, you will get that x1 equal to 0, x2 equal to 0, x3 equal to 0, but it is not possible. Therefore at the time you have to consider any one of the row arbitrarily. That means x1 plus x2 plus x3 equal to 0. Even second also, if you are taking x1 plus x2 plus x3 equal to 0. Third also, in the ratio, only the ratio is there, but all the equations are x1 plus x2 plus x3 equal to 0. At the time arbitrarily we can assume that this case, only this case, arbitrarily we assume that, let us assume x1 equal to 0 means we will get that x2 plus x3 equal to 0. That means x2 equal to minus x3. Then the second eigenvector is 0 1 minus. Similarly, once again we have to assume because we need to find that for lambda equal to 1 we need to find the two different eigenvectors, but the eigenvalues are repeated. So once again we can take that x2 equal to 0. If we are taking x2 equal to 0 in x1 plus x2 plus x3, then you will get that x1 plus x3 equal to 0, x1 equal to minus x3. Therefore, x3 equal to 1, 0, minus 1. Okay, so these two cases are very important to find this. So therefore, 1, 2, 3, 0, 1, minus 1, 0, minus 1 are the eigenvectors for the eigenvalues 7, 1, 1 respectively. Okay. One more problem we can do. Actually, it is a non-symmetric matrix. The given matrix is non-symmetric matrix. This matrix is the non-symmetric matrix. If it is a symmetric matrix, then how can we find the third eigen vector? Okay, see, find the eigenvalues and eigenvectors for a equal to 6 minus 2 2 minus 2 3 minus 1 2 minus 1 3. See here, 6 minus 2 2 6 minus 2 2 minus 2 3 minus 1 minus 2 3 minus 1 2 minus 1 3 2 minus 1 3. Therefore, A is symmetric matrix here. For this case, how can we find it? So already we have discussed in many problems how to find the eigenvalue eigenvector. Here, first we can find the characteristic equation. Characteristic equation is mod A minus lambda I equal to 0. So when you are finding A1 here, A1 is sum of diagonal elements that is equal to 12. A2 is sum of minus of A minus of diagonals of A. So that is equal to, first element is 3 minus 1 minus 1 3 plus second one is 6 2 2 3, third is 6 minus 2 minus 2 3. So This value is 9 minus 1 plus 18 minus 4 plus 18 minus 4. So that value is 36, and then A3 is determinant of A. This determinant of A is, see here, 6 into 9 minus 1 plus 2 into minus 6 plus 2 plus 2 into 2 minus 6. That value is 32, you can calculate. So therefore the characteristic equation is lambda cube minus 12 lambda square plus 36 lambda minus 32 equal to 0. See here, 1 minus 12, 36 minus 32. You can use the calculator to find that roots of the matrix if you are finding the difficult to find by using the synthetic division method. Okay, fine. So here it is A, B, C, D is there, but the total is not 0. Even if you are taking that alternative element, that is also not equal. So therefore we can try directly to here. If you put 0 here, 1, 2 into 1, 2 here. So here you will get that minus 10. 2 into 10 minus 20, then it is 16. 2 into 16, 32, will get 0. So 2 is the one of the root. 2 is the root, since you are getting the 0 here. Then you down one power here, lambda square minus 10 lambda plus 16 equal to 0. When you are solving, lambda equal to 2 comma 8. Therefore the eigenvalues are 2, 8. But actually you have to write that first a non-repeated value. 8 you have to write in front. 8 you have to write in front. The 2 are the repeated eigenvalue. So first we have to find that the eigenvalue for that non-repeated eigenvalue. What is A minus lambda I? So you can write the heading to find eigenvector. To find eigenvector, A minus lambda I is into x equal to 0. This matrix is, okay, now write 6 minus lambda minus 2 plus 2 minus 2 plus 2 here, then minus 3 minus lambda in diagonal, minus 1 minus 1 here, then 3 minus into x1 x2 x3 equal to, when lambda equal to 8, case 1, first you have to take that the non-repeated eigenvalue when lambda equal to 8. When lambda equal to 8, the matrix is 6 minus 8 is minus 2, minus 2, 2. Second one is minus 2, minus 3, minus 3, 8 is there now, and lambda equal to 8, minus 11, minus 1, then 2 minus 1, 3 minus 8 is minus 5. Plus 3 or plus 3. The matrix is plus 3. It is not minus 3. Plus 3 only. See the matrix. Matrix is plus 3 only, not minus 3. Plus 3 minus lambda. So that value is not minus 11, minus 5. Plus 3 minus 8 is minus x1, x2, x3. Even a single place you should not change that plus or minus, then you will get that wrong answer. So you have to write carefully that 6 minus 2 plus 2, 6 minus 2 plus 2, minus 2 plus 3 minus lambda, plus 3 minus lambda, minus 1, then 2 minus 1, 3 minus lambda. So minus 2 minus 2, 2, minus 2 minus 5 minus 1, 2 minus 1 minus 5. So take the two non-identical rows, x1, x2, x3, x1, x2. Here minus 2, minus 2 plus 2, minus 2, minus 2, minus 5, minus 1, minus 2, minus 5. So what is x1? x1 is 2 plus 10. x2 is minus 4, minus 2, minus 6. x3 is 10, 10 minus 4. Therefore this value is x1 is 12. 12 is 12 minus 6 plus 6 na? So 2 minus 1 plus 1. Second one, for lambda equal to 2, case 2, or lambda equal to 2, the matrix becomes lambda equal to 6 minus 2 is 4, 4 minus 2, 2. Second row is minus 2 plus 3 minus 2 na? So minus 2, 1 minus 1. Third one is 2 minus 1 plus 1. x1, x2, x3. You can see here all the rows are identical. All the rows are identical. You can see that 2 minus 1 plus 1, 2 minus 1 plus 1, 2 minus 1 plus 1. So if you are solving this, you will get that is equal to 0. So therefore it is not possible. We can take that 4x1 minus 2x2 plus 2x3 equal to 0. That means 2x1 minus x2 plus x3 equal to 0 you will get. So arbitrarily any one of them equal to 0. In case if I take that x1 equal to 0 arbitrary, for example, arbitrarily can take x1 equal to 0 at the time x2 is what happened? X1 equal to 0, no? So x1 equal to 0 means minus x2 plus x3 equal to 0, x2 equal to x3. So that means 0, 1, 1 is the second eigenvector. You have to find the third eigenvector by using the property if the given matrix A is a real symmetric matrix, then the eigenvectors are orthogonal inverse. Are orthogonal in pairs. Okay. So using this property here, we can take that x3 equal to A, B, C. Then we can use this property x1 transpose x2, x2 transpose x3, x3 transpose x1 equal to 0. But what is x1? x1 is 2 minus 1, 1. x2 is 0, 1, 1. Multiply this 0 minus 1 plus 1 equal to 0. It is satisfied. For the second one, x2 transpose x3. x2 transpose x3. x2 is 0, 1, 1. x3 is A, B, C. So that is B, C. Similarly, x3 transpose is A, B, C. x1 transpose x1 is 2 minus 1, 1. That means 2A minus B C equal to 0. So therefore, if both of them equal to 0 means, then we have to solve by using that usual method. Continuously write that A, B, C, A, B. What is A value for first one? 0, 1, 1, 0, 1. Second one is 2 minus 1, 1, 2, minus 1. So here 2 minus 1, 1, 2 minus 1. These values are getting from equation number 1 and equation number 2. So solving 1 and 2, we will get that A. As usual, you can write that, leave that first column, then 1 plus 1. B is, leave that first column, 2. C is, leave that column, then minus 2. So therefore, what is A is 2, B is 2, C is minus 2. Therefore 1, 1 minus 1 is the third eigenvector. That means x3 is 1, 1 minus 1. So which is satisfying that the orthogonal inverse. So if it is the repeated eigenvalue for the symmetric matrix, we have to use the two eigenvector for symmetric and repeated eigenvalue problem. Use these two eigenvectors to find third eigenvector. Any doubt is there? Otherwise, we can take the next. Okay, so these are the two problems we have discussed. For that, repeated eigenvalue when the matrix is not symmetric, when the matrix is symmetric. So this point is important. Okay, so this is that problem. Even for practice you can take some more problem. Find eigenvalue and eigenvector. A equal to one problem you can practice 3 minus 1 1 minus 1 5 minus 1.
Sir,
Ah,
can you explain one more time, sir?
which one?
From same eigenvalues question.
Yeah,
Uh, from case 2 to sir.
yeah, here case 1 is there, no? That case 1 understood, huh?
Oh,
8 by
yes, sir. Case 1 understood.
understood. So for case 2 you have to write that matrix. See, because case 2 and case 3 are same, na? 1
Yes, sir.
comma 2. So at the time what happened is you write the matrix. There is no doubt in matrix writing, na?
Yes, sir. No doubts.
2. So 4 minus 2 2 minus 2 1 minus 1 2 minus 1 1. This matrix
Okay,
is
sir.
there, but see this first row, second row, third row. In the first row itself 2 minus 1 1, 2 minus 1 1, 2 minus 1 1, all are same. It is the identical row, identical rows. When it is identical rows, no need to consider all. You can take any one. You can 4x1 minus 2x2 plus 2x3 equal to 0, or finally 2x1. Anyway, you will get the 2x1 minus x2 plus x3 equal to 0.
Yes.
Is it not? So this one. Here arbitrarily I take that x1 equal to 0. If we are taking x2 equal to 0, at the time also there is no problem, because once again I will do here. What is x1? 2 minus 1 1. I am doing here. X1 is, so root work I am doing here. What is x1? 2 minus 1 1, I think. Yeah, I will check it one more time. Yeah, 2 minus 1 1. Here I am considering that equation is 2x1 minus x2 plus x3. 2x1 minus x2 plus x3 equal to 0. What beginning I have considered? X1 equal to 0, na? In case x2 equal to 0, what happened? 2x1 plus x3 equal to 0. Is it not able to get?
Yes, sir.
So 2x1 equal to minus x3, x1 by 1 equal to x3 by minus 2. But you have to check it whether it is satisfying or not. In case if I write that x2 as, what is x2 here? 1 0 minus 2. What is x1 transpose x2? Can you tell me? X1 is 2 minus 1 plus 1. X2 is 1 0 minus 2. So multiply this, 2 minus 0 minus 2. That is also equal to 0. So now using this, how can you find the third eigenvector? For the third eigenvector is, if x2 transpose x3 equal to x3 transpose x1 equal to 0, then only that condition is satisfied. Okay, I don't know that x3, so generally I can take that x3 equal to a b c. Simply we can write that a B, C, A, B. First equation is what? 2 minus 1, 1. Here you can use this 2 minus 1, this value 2 minus 1, 1, 2 minus 1. Second value is 1, 0 minus 2. Using these values 1, 0 minus 2 directly. Even no need to write this x2 transpose x3, x3 transpose x1. Directly we can use it 1, 0 minus 2, 1, 0. So now we can find that A. To find that x3 value, what is A? Leave that 1. Then you will get the 2 here. B is, leave this 1. 1 plus 4, 5. C is plus 1. So 2, 5, 1 is that x3. What we have got already? We have got already the different value. See, 2 minus 1, 1, 1, 1 minus 1. Based on the case, the eigenvector may be vary. Not able to understand again? See, x1 is 2 minus 1, 1. Previously, I have taken that x1 equal to 0. I got the different eigenvector. Now, I am taking that x2 equal to 0. I get the different eigenvector. In case if you are taking x3 equal to 0, see, that eigenvector is not unique for any eigenvalue. It is repeated means then we are not able to predict that. So at the time, because some person may take that x1 equal to 0, some person may take that x2 equal to 0, some person may take that x3 equal to 0. At the time, we will get the different eigenvectors x3. Okay, that procedure is able to understand that. Okay, fine. Thank you. And if any doubt is there, I will be available in my staff room 1021. My staff room number is 2B1021. You can contact me anytime. Okay, thank you. Now you can
Thank you.
now you can leave the class. Please, if any doubt is there, once again you go through this video, easily you can understand this.
So
Yes, any other doubt is there? Any